Hi, everyone. Welcome to the Bee Conservancy's Spring Awakening webinar with Crown Bees. We're so excited to have you today. And I just want to go over a few hive keeping rules to get us started while we wait on a few other attendees to join us. And just a few notes. If you would like to change your name or add your pronouns and your organization, you are welcome to do so. All attendees are muted by default. And we are going to be turning off the chat during the presentation, but we will have a Q&A feature. So you can drop all of your questions in the Q&A section, and we will get to those juicy questions. Next up, I'm going to mention a few other upcoming events that we have that are hosted by the Bee Conservancy. We are doing another webinar on May 16th, that's next Monday, on a hot topic, pesticides and the race to curb neonicotinoids. And if you're in the New York City area, we are celebrating World Bee Day this year on Governor's Island. And that is on Saturday, May 21st. If you're in the area and you want to register for either of those, you can check the link at the bottom of this slide and register online. So thank you so much for waiting. And I am going to turn it over to our lovely moderator today, Rebecca Louie, the Executive Director of the Bee Conservancy.
Thanks so much, Mary. Hi, everybody. Thank you so much for joining us today. As you know, spring is a very buzzy time in nature, and as things warm up, so do our precious bee populations. So, as you may know, there are more than 20,000 species of bees on this planet and about 4,000 in North America. And together, this amazing workforce pollinates 80% of the world's flowering plants and 1 in 3 bites of food that we eat. And so today I am incredibly thrilled because we will be introducing some very expert VIBs to introduce you to a few of these species and what they're up to this spring. First up is Dave Hunter, who will tell us about cavity nesting bees. Dave is the founder and owner of Crown Bees, whose vision is simple: to help gardeners and farmers increase pollination and food production with responsibly managed solitary bees. Dave collaborates with researchers to set the standards for best practices in solitary beekeeping, and he teaches people just like us how to successfully raise solitary bees and grow fresh, healthy food. So a quick reminder, after the presentations, we're going to have a quick hive side chat with our panelists, and then we're going to open it up to Q&A. So remember to just drop your juicy questions in the Q&A, upvote any ones that you're thinking as well, and we'll start the conversation after the presentation is done. Thanks so much, and take it away, Dave.
Thanks, Rebecca. Appreciate it. It's so fun to be here. I love teaming with, the Bee Conservancy is a group that we've been touching for a long time, and I just appreciate their vision matches ours. It's all about the bees and what we can do to keep things healthy. So what I appreciate what Rebecca was saying at the very beginning, there's an awful lot of bee species out there. So when we're looking at 20,000 in the world, 4,000 in the US, one more little subset of that, of those 4,000 species of bees in the North America, guess how many make honey that are native? None. So the industrious honeybee was brought in a little later, and I think Guillermo will be talking about that. But when we look at these 4,000 species of bees here, or 20,000 in the world, about 3/4 of those bees nest in the ground. So we're calling them ground nesters. So roughly in the US, 3,000 species, or North America, 3,000 are in the ground. And then 25% are, 1,000 species nest in various size holes. Small bees use small holes, large bees use large holes. So specifically where my company focuses on are the bees that nest in cavity nesting things, so reeds, paper tubes, wood trays. When you're looking at solitary species, every female is a queen. She does the egg laying, she does all of these things. They work by themselves. They are, we call it gregarious. The mason bees want to be next to each other in a hole, not necessarily in the same hole. So each female owns her own cavity that she nests in. They're so gentle. You can put your hand over the hole, you can stand in front of it. The bees will come out and they bonk on your face. The bees are, they're doing everything. They're gathering the pollen, they're gathering the nectar, they're laying the eggs, they're sealing these chambers. They don't have time to do all of this work and sit there and defend the hole. So they don't. They're just a gentle little bee. They are a bee with a stinger. You can grab it in your hands and squeeze tight and you'll get stung, but the venom in a solitary bee is much, much less than a social bee. So from all we've read, there are no cases of anaphylactic shock from just getting stung by a solitary bee. Most of these bees are very hairy. It's called kind of scopa. This is the hair all over these bodies. Man, they are just great for gathering pollen. And these mandibles in front, these little pincher looking things, these bees use this for gathering mud, cutting leaf bits, gathering tree resin. All these different species use their front mandibles quite well. And I'm clicking on my slide. Rebecca, if you could push it forward one.
Yeah. There you go.
There we go. Okay, so mason bees are, back that up one, we're kind of moving around. Okay, back up one slide, I think.
Hey, Mary, could you back up one slide, please?
Yes, we're having a glitch. Sorry, guys.
Okay, now forward. Thank you. Okay, so what's really important also to understand is how these bees are gathering their pollen. A mason bee, I'm going to say they're inefficient pollen gatherers. They're belly flopping into a flower. This pollen is carried dry and loose all over their hairy bodies. And so the next flower they fly into is just belly flopped in and the pollen's spreading everywhere. And so researchers are saying most of this pollen from these bees are just spreading everywhere. Another part that's kind of interesting, a honeybee is amazing at gathering the pollen. So you can see back here, this is their pollen pockets. They're hitting typically a tree, moving most of the pollen onto their bodies back to a tree, whereas your solitary bees are meandering around. And the difference is, and I'm saying not one's better than the other, but the difference is that the solitary bees are typically cross-pollinators, because that pollen is just being spread from tree to tree. And move me a slide, please. There we go. In the spring, you're finding, well, actually throughout the entire year, if there's pollen out there in the early spring in dandelions or tulips or whatever, if a pollen source is there, a bee was there thousands of years ago. So as you watch that pollen flow all the way through into the fall, bees show up at different times. And so in particular, we're looking at the solitary bees. They all show up about 6 weeks at a time. All of these bees are living 6 short weeks. So in the early spring, some bees are coming out in March or April. They're dead 6 weeks later. Other bees are coming up in May or June, July or August. So it's fascinating. In the spring bees, the one that my company works with, we're sending cocoons in the mail to people across the country. We're helping people in the early spring with the mason bee. Almonds, cherries, apples, strawberries, tulips, dandelions. These bees are just spreading pollen everywhere. They work really low. The front bees work really low temperatures, 17 degrees Celsius, 50, 55 degrees Fahrenheit. They're just an amazing early spring pollinator. Next slide, please. And just a little bit on the life cycle. And when I'm saying this, I'm talking about 90% of the species across the world are solitary. And so you've got spring setup, and then you've got a summer setup, okay? The spring bees, they overwinter as adults. So cocoons, the adult bee is inside there. Early spring, depends, if it's an early bee, they're gonna come out, they're gonna mate with their females. The boys are dead within a couple weeks. The females are out there gathering pollen, nectar, stuffing these deep into a hole. She'll lay an egg, so probably 30 trips worth of pollen gathering, has about a pea-sized bit of pollen available. She lays her egg inside there, and dependent upon the species, they're gonna close that little chamber deep in that nesting hole with mud or tree resin or chewed up leaf bits or pebbles. There's a whole lot of things they do. Pollen egg something. So in a nesting hole, you might have by species 6 egg chambers or 10 egg chambers. The females are dead. 6 weeks later, they're dead. And the eggs they laid are next year's bees. So those eggs quickly are going to hatch. They become little larvae. They cruise through to consume all of the pollen in there. Inside of the nesting holes are typically females, where these are protected. The outside of the holes, an unfertilized egg, are males. The queen chooses what she wants. And these cocoons have, they've gathered all the pollen, become large larvae, and probably deep in the summer, metamorphose from, as they're spinning their cocoons, from a pupa all the way to an adult bee, where they overwinter as adults. Real simple. And on the next slide, the other side of these things, back up one slide. The other side of this is summer bees. And a summer bee is just a little different, that they overwintered as a larva. And they take the early spring and the front end of the summer to metamorphose from a little larva inside a leafy cocoon, and then move themselves all the way to an adult bee. And these are, we typically are moving leafcutter bees from across the country that are there for summer gardens and summer pollinations. But it's a very interesting, that front end, as the spring bees that start off as adults come out right away. And then the summer bees are using the warmth of the warmth of the air to slowly work themselves out. And so some of these summer bees are coming out in June. Some of them show up in August. There's the overview. Guillermo, yours.
All right. David, thank you for that introduction to solitary bees. Rebecca.
Well, I just wanted to make sure everyone knows just who's on the mic right now. So I just love to do a quick introduction to Guillermo, who is the Bee Conservancy's founder and chief melittologist, which is basically the big bee nerd of our org. He is a master beekeeper, master melittology candidate, and has been an urban beekeeper for over a decade. And having grown up in a food desert, Guillermo truly believes that bees are key to transforming our food system and ensuring that everyone has access to healthy local foods. And it's why he started this organization. So now let's get a little social with our spring social bees.
All right, let's dork out with some honeybees. Thank you so much, Dave, for that intro into solitary bees, and Rebecca for that intro. I'm unbelievably excited to be here with everyone, and thankful that for everyone that's joined us today. So we're going to talk about spring social bees, honeybees. Now, honeybees are some of the most fascinating creatures in the world. And honeybees are actually a really rare type of bee. They're social bees because they actually prefer to live in a community. As Dave mentioned, and Rebecca previously, there are 20,000 species of bees in the world, but only 9%, about 2,000 of them, are actually social. What social means is they like to live in communities, maybe a few dozen. In the case of bumblebees, which are also social bees, a few hundred. But when it comes to honeybees, they're extremely rare because they live in a highly complex society. In a honeybee hive, it's not unusual to have 20 to 40,000 bees in there. Some hives even have as much as 80,000. Now, I don't know about you, but if I saw 20 to 40,000 people in a community, I'd probably call that a small city. So unlike the independent solitary bees, honeybees cannot survive on their own. Honeybees are part of what's called a superorganism. That is a communal cooperative unit that can only survive through all its members. And that is partly because the work is divided amongst them. One of the biggest roles in the hive is that of the queen. There is only one queen to rule them all. She is the one that lays all of the eggs in the hive. In fact, to keep her rule, she actually gives off pheromones that prevent all of the other bees that are female from being able to lay eggs. Now, you know, Dave mentioned the solitary bees and how there are some spring bees and summer bees. Now, in the case of honeybees, they actually survive throughout the year. So you see the same species from April to November. And when you're seeing those honeybees out there, you're actually seeing multiple generations together. So solitary bees, as Dave pointed out, the adult lays its egg, the adult passes away, and before the next generation is born. In a honeybee hive, you actually have the queen and all of the worker bees who are all her daughter. And you will have those worker bees at various stages, whether they're adult or larval stage. That is very uncommon among bees. Now, what's also uncommon about these fantastic honeybees is that they produce honey. And they do that because they gather nectar. They also produce wax, which they actually excrete from their bodies. Because they produce wax, because they produce honey, because they're such great pollinators, they've been actually semi-domesticated. So they're able to live in a hive that humans can carry around from location to location for pollination services. This is something that humans have been doing for 4,000 years. There's documentation that shows that the Egyptians were the very first beekeepers. They actually carried beehives up and down the aisle for pollination, the Nile for pollination for about 4,000 years ago. In fact, because honeybee hives are so mobile, they were actually brought over by colonists from Europe. So honeybees are not native to the US, they're native to Europe, to Asia, and to Africa. Now, in this complex society, you actually have three castes or types of bees. You have the queen bee, the worker bee, and the drone. We're gonna dive into each of these bee types and what they do during the spring. So let's click over to the next slide. So the queen bee. Now, queen bees are not always hard to spot. Take a look at this image. Look for the bee that is the largest because queen bees are typically double the size of other bees. The reason for that is queen bees are egg-laying machines. So she actually begins laying her eggs in the winter. The bees actually keep together to stay warm with the queen at their center. And worker bees will excrete from their mandibles or their jaws royal jelly, feed that to the queen, and that stimulates her egg production in the winter. But it's in the spring that that egg production really gears up, and she will lay up to 2,000 eggs a day. Now, sometimes the hive decides that it's time to get a new queen. Perhaps the old queen isn't laying as well as she used to. So what these worker bees do is they again excrete that royal jelly and they will feed it to several of these eggs. And that begins the process of raising a queen. Queen bees are queens because they've been fed royal jelly throughout their period as a larvae. Now, because there can only be one queen in a hive, the first queen bee that hatches immediately goes to kill her sister queens. So this is a real Game of Thrones type of story where you have the emergence of a queen and then murder. Now, in the spring, this newly born queen is a virgin queen. And so she will fly out to mate with male bees called drones and to gather their genetic material. And as with the solitary bees, this queen bee can decide whether to fertilize an egg. If the egg is fertilized, it becomes a female bee. Or she can decide to not fertilize the egg, not put the male genetic material there, and that will be an unfertilized egg, a male bee that has 100% of her DNA profile. It's incredible. So now she sort of decides if she picks if she lays a male or female egg. Now, the reason I wrote down that it's sorta is because it's actually the hive that decides. So one of the roles of the worker bee is to decide the ratio of males to females in the hive. If they feel they need more males, they will create a larger wax cell for the queen to lay her unfertilized egg in. If they feel they need more females, they'll create a smaller cell. The smaller cell is because worker bees are smaller. Now the queen bee, she's that egg laying machine. That's her only job. So she is cared for nonstop by her attendants. They feed her, they groom her, they even carry her poop out of the hive. Talk about getting taken care of. So hopefully you looked at this image and have spotted the queen bee. I'm gonna try to drop a circle to identify her for you. Let's see if that circle drops. There we go. So you can see the queen bee there, right there at the center of the image. Now let's talk about these worker bees that are her daughters. So worker bees are all female. There we go. So worker bees are all female. They literally do all the work for the hive. Does that kind of sound familiar to you? There are a lot of species where women really do most of the work. And as I mentioned earlier, the hive is almost dormant in the winter. The adult bees are all tightly clustered together with the queen at the center. And during this period, this winter period, those worker bees have one job, which is to keep the queen warm and alive. So what they do is they actually have a number of worker bees that are called heater bees. These bees have a job of vibrating their wings to create heat, to keep that cluster, that ball of bees warm, and to keep the queen warm and alive. That's incredible. Now in the spring, when the sun comes out, the bees have many more jobs. They start the division of labor. So that division of labor is actually dependent on their age. So a brand new bee, one that's newly hatched, 1 or 2 days old, their first job is housekeeping. From that, a few days later, they actually graduate to taking out the trash. It could be wax particles or taking out dead bodies. They're actually undertaker bees. Now, at the end of their life cycle, which is about 22 to 35 days, they become foragers. So when you're out there in the garden and you see honeybees flying around, those are bees at the last stage of their life. Those are the oldest bees in the hive. And they will fly up to 5 miles for food and water. Now, we normally think of honeybees as collecting nectar, but the average size colony actually brings in about 100 pounds of pollen in every season. Pollen is a critical part of the honeybee diet. It provides a wide range of nutrients from proteins to carbohydrates, vitamins, and minerals. So the bees collect this pollen to feed their larvae. They return to the hive and put that pollen into a waiting cell to be fed to the larvae later. Now, as a result for their need to collect so much pollen, they've evolved to have these pollen baskets. You'll see in the photo, the bees and their hind legs have this yellowish orange pollen basket. Now, this is different than solitary bees, which, as Dave mentioned, carry a lot of the pollen on the underside of their body or on the hairs on their body. These aren't the only ones that have pollen basket, but that is one way that you can identify a honeybee versus another bee. Now, let's talk about those male bees in the hive, the drones. Let's see. Now, the drones, the male bees, do not exist in the hive in the winter. They're exclusively born in the spring and in the summer, and they make up about 10% of the hive. They're oftentimes confused with queen bees because of their large size. In this photo on the left side, you're going to see a really large bee. The way you can tell that apart from a queen is, number one, male bees do not have stingers, only the females do. Very interesting. Also, male bees have these gigantic eyes that you can see there. They're practically touching each other. The reason their eyes are so big is because they have one job in life. Procreation is the reason they exist. It's the primary purpose they're around, because these drone bees are really high maintenance. They come to the hive, other bees feed them, then they go fly waiting for a virgin queen. They usually wait in a tree branch hundreds of feet in the air. These areas are kind of like a singles bar. They're called drone congregation areas. And all the male bees will hang out there in these branches waiting to spot a queen bee, a virgin bee with their big eye. Now, if they're lucky, or some might say unlucky, they actually mate with the queen bee. But this is a really major act because they die in the process. So we know bees have stingers. Those stingers are actually barbed. Well, when it comes to male bees, their private parts are also barbed. So in the process of mating with the queen, at the moment of release, they try to withdraw, but are not able to. And so their member actually rips out of their body and pulls out some intestines. They flop backwards and die and land on the ground. So to me, it sounds really tragic. But again, that is their sole purpose in life, which is to pass on their genetic material. Now, most male bees don't actually get the opportunity to mate with the queen bee. Well, tough luck for them, because since they don't do anything except eat and hopefully mate, the worker bees have no patience for them. They will not tolerate having these bees around. So in places where it's colder weather, like up north, you will see these worker bees systematically expelling these male bees from the hive, usually when it gets cold, like October time. These these male drone bees end up getting kicked out, and they essentially just starve to death or freeze to death outside the hive. That's why there are no drone bees in the winter. So we've talked about the individual bees and some of the events that happen during the spring. Let's actually talk about the colony, because as we mentioned, they're a super organism. So as I mentioned earlier, the hive is virtually dormant in the winter, and they're clustered together for warmth with the queen snugly in the center. Now, during this time and in the spring, a lot of bees die because during the winter period, a number of them die. So what a lot of beekeepers do is they start feeding their hive. They will feed them pollen patties. Sometimes they will feed them sugar water to strengthen the hive. Now, if a beekeeper is lucky enough to have a strong hive that's completely full, and sometimes like just has a massive number of bees, the beekeepers will actually split these strong hives and create two hives. They'll take half of those bees and put them in another hive. Now, on occasion, and the honeybee hive don't survive the winter, or maybe a beekeeper wants to start a new hive. So what a beekeeper will do is, as you can see in the photo on the top right, they will buy a package of honeybees, which you can actually have shipped through the US Postal Service. It's incredible. So these bees travel 2 or 3 days to the Postal Service, arrive at the beekeeper, and then the beekeeper will open up the box and basically drop those new bees into a hive where they take residence. Now, in the springtime, the bees only have a few goals, which is number one, to forage for that pollen and nectar, to feed that pollen, to grow the population of the colony, and also, of course, to reproduce. The queen reproduces on an individual level, but this is a superorganism. The hive also reproduces. It reproduces by creating something called a swarm. Now, what happens is the hive will expand, the number of the population will increase, and the old queen will take half of that population and fly out to start a new colony. The other half will stay with a newly born queen. That process is called swarming. And in this photo on the bottom, you'll see that half of the hive that has flown out with an old queen and has landed in a tree branch, waiting to find the right tree hole or other area for it to take up residence. So when I mentioned earlier that beekeepers will split a hive, sometimes they actually will split the hive to prevent this process from happening, because nature, the beehive colony, it wants to increase its numbers and it wants to split. So a beekeeper will do that in advance for them. So let's talk about one of our favorite bee products, which is honey. And I'm clicking over to that slide. There we go. So honeybees are chemists. They use enzymes in dehydration to transform sugar into to transform the sugar that's in nectar into this super saturated power food, that's honey. And it actually takes 12 bees their entire life's work to just make 1 teaspoon of honey. So next time you're putting that honey in your tea, keep that in mind. It also takes about 2 million flower visits to create 1 pound of honey. Now, what's interesting is you can actually tell a lot from looking at honey. You can tell if it's a spring honey or if it's a fall honey, because in the spring, that honey is made up of the nectars of spring plants, such as fruit trees, spring flowers, and linden. As a result, you get a lighter, more golden honey. Fall honey is made out of those fall blossoming plants, such as asters and goldenrod, so you get a much darker honey. So when you're looking at honey to purchase, or to get from a beekeeper, that's something that you can know to tell if it's spring honey or fall honey. And summer honey is usually in between. It's sometimes a mix of both. Now, bees collect this nectar in a second stomach that they have that's called the honey stomach or the honey crop. And while that nectar is sitting there before the bee gets into the hive, it actually mixes with some enzymes that the bee naturally produces, which breaks down the sugars in the honey. Now, when the bee returns to the hive, it places that nectar into a wax cell, and yeast is naturally occurring in the hive, and that yeast actually helps this transformation of nectar by fermenting that nectar into honey. So it's important to keep the hive very warm, not just for the brood. The brood needs temperatures in the 90s to thrive, but also for the honey. The reason is that flower nectar is about 80% water, 20% sugar, but honey is actually the opposite. Honey is actually about 80% sugar, 20% water. So keeping the hive warm helps that nectar to evaporate. But the bees don't rely just on the warmth of the hive. They also rely on another role that some bees in the hive have, which is called the fanning bees. There are some bees that actually stand over the nectar, and all they do is spend their day fanning their wings to fan out and evaporate that water that's in the nectar to transform that into golden honey. That's our journey with spring's social bees. I hope you found it interesting. I look forward to your questions. And at this point, I will turn it over to Rebecca.
Thanks, Guillermo. I always love the idea of a honey stomach because I sort of feel like I have one. I've got to make honey just to consume it like a crazy person. But thank you, Dave and Guillermo, both for this amazing peek into the world of bees of spring. And I think now we can just kind of explore the panel itself, right? Yes, we're here to talk about spring, but kind of on a much higher level. We're here to talk about bees, and I'd love to hear from you, Guillermo and Dave. The question of the day, why is it so important to support these important pollinators and their other pollinating friends?
Want to go first, Guillermo?
Sure. So, it's important to support these pollinators just for the fact that they're these amazing species. But as was mentioned earlier, they're also critically important to the health of the planet and to our food system. Because the growth of almost all of our fruits, nuts, and vegetables, those would be impossible without these bees. There's research that shows that without bees and bee pollination, we'd lose 100% of our almond crop. We'd lose 90% of many of our berry crops and apples. This is a real big issue because in the US alone, there are 40 million people that suffer from food insecurity, and 12 million of those are children. If we want to help keep our population fed, especially these people that are suffering from food insecurity, we really need more food, and we need to support bees, because if you want local food, if you want any food, you need these bees. Dave.
And then I'm gonna say yes, okay? And then realizing that the big leaf maples and your trees out there, without bees to move that pollen around, some trees are wind pollinated, maybe your conifers, but so many trees which would provide the habitat for the deer and the owl and the squirrels. And then you drop down to the ground level and you got all these bees out there everywhere, creating seeds for the quail to eat, for the mouse to eat, which then, the quail and the mouse are fed up to the chain to the eagles and the wolves and everything. But without the bees out there, this whole planet slows down to nothing. Okay, so it's not just about us, which, it is about us, but there's so much more than us that's out there at stake. So to answer your question, Rebecca, I'd say really important.
Yeah, I mean, when you think about it, the buzzword, right, is that bees are considered a keystone species, and it's literally because they're essential to all of these ecosystems thriving. So that 1 in 3 bites of food, et cetera, food security means not just humans and like the snacks on our tables, but everyone out there who's eaten something, which is basically everything alive on the planet.
And when you said that 1 in 3 bites, the other part that people don't realize is that take a carrot, and we're just putting seeds and cabbage out there, but that carrot plant is 3 or 4 feet tall with this ray head of flowers that without a bee on top to make the seeds, you don't get carrots for the next year. So it's even more than just the immediate fruit, you know.
Mm-hmm.
Well, so then there's this question of like the why. You know, about a quarter of the world's 20,000 bee species are in danger of possible extinction or endangerment. And like, what are the factors that you're seeing that are basically contributing to the kind of precarious situation that bees are in right now?
Okay, do you want to take this first?
Okay. Chemicals. Well, probably, okay. I'm going to say humanity is probably, you know, and then the underpinning of where we're doing it. There's a lot of toxic chemicals out there from neonicotinoids, there's, okay, chemicals would be my first pick. And it's innocent, whether it's in your, directly in your yard, or what we're learning is your neighbor's yard. The bees from my yard, you know, you're raising everything organically, but the bees in your yard are out there hitting your neighbor, which sprays, which comes in, they're bringing now tainted pollen, and as that tainted pollen goes into that nesting hole, it kills the larva inside there. And so you're so good, but your neighbor is doing things. And so, okay, there's one. Guillermo, you're next.
Yeah, no, I totally agree with Dave. And it's really interesting because a lot of the poisonous chemicals or pesticides that we found to kill bees and other insects, many of them have been banned. But there's a newer generation of chemicals that are actually more insidious. Neonicotinoids, for example, because they don't outright kill the bee, they open the door for other illnesses to kill the bees. They weaken bees' immune systems. And there's research that shows that when these pesticides are out there, these bees are more likely to have fungal illnesses or to have be attacked by mites and things like that. Now, in the case of neonicotinoids, those have been banned in Europe, and there are a number of states in the U.S. that have started banning them. So, for example, I believe California and Massachusetts.
No, I was going to add one more thing. And when we recognize, I think the writings on the wall that neonicotinoids are kind of fading out, and there are pesticide companies already working on the next classification, so that's coming in. And we're working with a researcher that has the most bee-safe product, and they're only focusing on the honeybee. When they put that product into the ground, it got sucked up into the plants. All the bees died within 3 days. Okay, and
wow.
So it's not neonicotinoids. It's researchers out there trying to understand the chemical play. So chemicals, it's an issue.
Yeah, and I promise everyone this is not a shameless plug for next week's very in-depth pesticide and neonicotinoid talk, which we are having. But you're both speaking to something really important because, chemicals like neonicotinoids, for example, specifically are actually systemic, right? So the idea is that it's not just like a surface type of chemical spray, but it's actually consumed by the plant so that every part of the plant becomes toxic, and then the soil becomes toxic as well around it. And so then you have, when Dave was speaking to things like drift from maybe your neighbor's pesticides getting onto your organic food, then we're starting to see this research around like these pesticides like appearing elsewhere, like in our water systems, et cetera, and tested up into other animals and even in human bodies as well. But getting back to the idea of what else is harming bees, we're starting to actually talk about this idea of land, right? And so what's the habitat situation like? Do bees have what they need and where they need to thrive?
So in the old days, you used to have the bees, a lot of them are nesting in the ground. We now have houses and roads and when you've got your monoculture where you're out there just plowing things over, the ground nesting bees have a tough time trying to go through that turned over. So for the ground nesters, it's tough out there. And then with our homeowners, the bees, long time ago, the cavity nesting bees used to go into your old dead trees that would be there or fall over. And no, we don't have any of those trees. And so, you know, the lack of available housing is a tough one for your both ground and cavity nesting bees. The third little piece out there, I'd say, would be food. When you go look at monoculture, so one crop, when you look at 1,000 acres of apples, for you got maybe 10 days, 2 weeks worth of food, and the other 50 weeks in the year is just Sahara Desert. And if all bees are coming out for 6 weeks, and you've only got in that one place 2 weeks of food, those bees are starving or just moving someplace else. So monoculture is a tough one.
Yeah, and actually something that impacts the amount of food or forage that bees have is something that hasn't been talked about a lot, but how climate change impacts bees. You know, 9 of the 10 hottest years have occurred since 2005. There's a lot of research that shows that heat stress actually reduces fertility rates in wildlife, and that this includes bees. There's been research specifically on bumblebees. On top of that, what is the effect of these very hot years? We have more droughts. We have more wildflowers. Wildflower decimates habitat, removes it completely. The droughts cause what's left to actually produce less pollen and less nectar, which of course impacts bees by reducing their population size. So very interesting.
Yeah, and I think even combining two of those ideas together, right? Like there's actually the physical space. So we're paving over areas. There's literally like the habitat non-existent, but then it's also what's blooming and when. And so the idea, I sort of feel like there's this question of what are you planting? You know, like there are all these beautiful ornamentals, love them, like they look great. But, you know, a lot of bee species over time have really co-evolved to connect with native species of plant, and literally down to the biology of like, you know, when a certain plant blooms for that 1 week in the Sonoma Desert, that's when the bees who feed on it pop out. And if it doesn't rain that year, nobody pops out. They just wait for next year. And it's really bananas, like evolutionarily speaking, like how important those relationships are. So like, as we're taking away those native species of plants, we're also taking away the diet that those native species of bees rely on, which makes me wonder, because we are definitely here for some hope. Life is hard enough. What can folks do to like mitigate some of this stuff that we're talking about, whether they're gardeners themselves or maybe have a bit of a brown thumb and may not be getting in the dirt, but like, how can we help?
To me, in your yard and in your area, it's pollen and nectar as early in the beginning of the year to late. So it's just that. If you can avoid spraying, that would be fine. And you know, realizing the solitary bees that we work with just go about 300 feet away, which is maybe a 6-acre radius. You're getting pollen everywhere. I think a honeybee, Guillermo, goes 4 miles, 5 miles.
Yeah, on average 3 miles, but they can fly, 5 miles forward.
So I think the source of food should be there. I would, what we recommend is do plant hybrids and beautiful things that maybe aren't good for bees. We all want to have beauty in our yard, and consider heirloom, old style plants that a double blossom rose really doesn't have anything in there. Look for plants that are heirloom and native to your area. That's what your bees are really going to be looking for. That's what they focused on their entire, evolution of that type of plant. So do some native things in your area. I think you can get that list from a local nursery, probably.
Yep. Just to add to what David said, which is spot on. I mean, making sure that you're planting forage for bees if you're able to. A lot of these spring plants really help sustain those early hatching bees. So especially trees, bees actually get most of their sustenance from trees. So if you're planting a linden or crab apple, which bees go crazy over even more than regular apple, or redbud, you're doing the bees a tremendous service. Yellow crocus, hellebores, which start blooming in the winter, those are great ones. And if you'd like to see the fruits of your labor, you can watch the bees and see what kind of pollen they're carrying back. Because if you see a green-gray pollen, well, that's the hellebore that you planted. If you see an orange-yellow pollen, well, that's the yellow crocus. And there are some really great pollen charts that you can see online. But if you're not a gardener, you can still do a lot. I think we all have the tools to really support bees and other wildlife. Number one, write to your local politicians to have them pass laws about the use of pesticides, especially neonicotinoids. You know, World Bee Day is on May 20th. You'd be surprised how many people aren't aware of it. So, you know, spread the word maybe on social media to just raise awareness of World Bee Day and the value of bees.
So if you know, one of the things of what can you do in your yard, we're given a lot of doomsday. Don't spray. For your ground nesters, leave some of your ground untouched if you can. Leave the leaves in there all winter long. Don't rake those away because your bumblebees are nesting in there. Do supply, everyone just put varied size holes, reeds, that you can take out. We teach you how to harvest these things in the fall. But if everyone just did one little habitat per yard, that would give you so much across the neighborhood. Simple, that, you know, that's your dead tree that used to be there. Those a couple, you know, you can do this and help the bees out.
Yeah, for some bees, your backyard is their entire world.
Yeah.
Well, thank you both. This was an incredible conversation, the presentations, this little chit chat amongst us. And now there has been a lot of action going on in the Q&A. And I will say Dave and Kim also like major props for this like great Q&A answer live real-time things. But I was wondering, Dave, maybe while Guillermo also takes a peek at some of these great honeybee questions that have come up, to pick a couple to answer live. Dave, were there some questions that you've gone through or that you'd like to chat about in the Q&A to address, like some faves or some really like, you know, questions that everyone has about the solitary bees?
A couple of the questions that were important to us, people are saying more people are aware of native bees and where are they coming from. If you're going to go out and purchase live mason bees or leafcutter bees, do check the source. We try to keep disease and pest control down. So our company sources bees from New York, holds them here and pushes them back to New York. That's important to us. So if you're going to go out and do this, just check on what, you know, where you're doing. I would say that's, we're careful with what we do. You should be careful as well, not bringing in bees not acclimated to your turf. That was one.
Actually, I see one that I like, and maybe this could be for both of you. So Melinda's wondering, I'm curious where the bumblebee fits into this process. Are they just as important to our orchards and gardens? You know, and bumblebees are like the fuzzy teddy bear of the bee world. So I feel like they're a little bit of celebrity status as well. And so I was wondering, you know, we didn't get a chance to talk about bumbles today. Could either of you provide some insights to our audience around like, who are these bumbles and where do they fit in?
From my perspective, bumbles are very similar to a honeybee, that it's a social. In the fall, the queen she's living her whole year, she's just passing on. She lays 4 or 5 queens and a couple little drones out there. Those queens are mating, getting all their sperm sacs from right there. And off they go into a 10-mile radius, looking to overwinter in grass, down mouse holes or whatever. And in the springtime, they're coming out. The first thing is just the queen. She's got her sperm from the following year. She finds her own little hole, makes a little cup for putting nectar in that she sourced, and then she sits there and slowly builds her brood up. And then now through this whole summer, she's still there laying eggs, and maybe might have 200, 250 total queens that are there. And then by August, September, she's fading and life begins anew. That's kind of bumblebee-esque.
Well, and oh, sorry, go ahead.
I was going to mention buzz pollination. So we talked about how great solitary bees are at pollinating because they're meandering, and honeybees are great because they have something called floral fidelity. They love to focus on one specific flower. That's why they're great for agriculture. If there's a row of apples and a mixture of flowers, they're going to go for the row of apples until they get all the apple pollen. But honeybees are not the best pollinators of a lot of the vegetables and fruit that originate in North America. Things like the tomato or the zucchini, the squash, those require buzz pollination. That pollen, a bee can't just go in and pick it out. It's kind of difficult. A bee actually has to hold on with its legs and shake it out. It buzzes its wings and vibrates it out. Honeybees can have the muscles to do that, but they don't know how. They never do it. But bumblebees and squash bees, for example, have co-evolved with these flowers and instinctively know to vibrate their bodies and shake out that pollen.
I love that. And actually, that's what I was going to actually cue you to tell the buzz pollination story. But what's also interesting is that honeybees, you know, getting back to the effectiveness of their pollination, they're great at gathering pollen. And they even have like little sacks on their legs, little packs to store that pollen in and bring it back to the hive, because the pollen is the source to like feed the babies. But because they're so neatly tucking it away into their legs and bringing it into the hive to be consumed by them very efficiently, like that idea of how much pollen they're actually spreading around versus like, you know, a cute little chubby bumble who's like super fuzzy, been buzzing all around and is covered in the pollen going from flower to flower. Like you can kind of see how some of that pollinator services, not disparity, but like the difference, right? And like the impact that one flight can take, whether you're landing in flower to flower covered in pollen, or you've tucked it in your legs and dropping some, but really bringing it back home for everybody else to eat. Great.
I'm scanning through questions and I see Sandra asks, what can we teach young people, children, about what they can do to save the bees? So we've learned there's more than one species of bees in the world. I think probably that one element, aware that there's other ones out there. Our website does teach. We've worked with Cornell to get teaching pieces on mason bees. I would reach into the curricula and talk with your teachers to maybe have the appreciation of it's not just human food, but it's full food for the planet. Is I think once we begin understanding that, maybe we'll learn to, you know, care for the bees.
Guillermo, any thoughts on kids and like inspiring and delighting the next generation of bee stewards?
Yeah, absolutely. You know, I think the Crown Bees actually has a really great educational site that includes lesson plans and also information on how adults or kids can support and welcome bees into their home. But also the Bee Conservancy has some really great lesson plans as well. So I think, you know, I noticed that there were some teachers that were part of this course. I'm so excited to have teachers and any parents, because you have a tremendous opportunity to instill a love for bees with the, you know, the little adults that you have in your lives. So.
Yeah, and I think one thing I would say just to add to that is really like, I'm always shocked, like when we do community events or whatever, at how much the kids actually do know. And it's pretty amazing how like they'll kind of like raise their hand during a bee lecture, know all of the answers, and then they'll be telling their parents and the adults in the back of the room. And so like, I think, you know, one thing I would encourage everyone on this call to do, kids or not, is just to get out there in nature and look around. We're always in a rush, and I get it, we all have places to be, but the magic of kind of stopping and being still and suddenly realizing, oh my God, things are moving around me, they're flying, that's interesting.
Rebecca, okay, so in my heather bush, whatever's buzzing in the summertime, if you can just take 5 minutes and try to count the species, you're going to find tiny little somethings and big bumblebees with an orange stripe or a yellow stripe, different species. Just to count the number of species is the awareness that, you know, your yard is an oasis for these girls.
Yeah, okay. And just to add to that, if you want to learn more about these, you know, six-legged neighbors of yours, you can always take a photo of that and upload it to this app called iNaturalist. I absolutely love it. You can upload a plant, any wildlife, but I love to upload bees that I don't know what species they are. And there's a team of people in the background that will identify that bee for you. Now, by knowing what kind of bee that is, you can have a better idea of what to plant. So for example, sunflowers are really fantastic for a number of solitary bees that only eat pollen from sunflowers. So that's a great way to discover those neighbors and learn how you can help them.
Well, and fun fact, the Bee Conservancy is on iNaturalist. So we have an umbrella project there, and we're now taking members because we're launching some really exciting projects in a few weeks that are literally exactly what Guillermo just described, and like getting to know the things flittering around you a little bit better. So I would encourage those iNaturalist fans out there, or people who just like using their phones and maybe don't want to go outside too much, to check us out there and join our umbrella project. We have maybe time for one more question. We're at 6 o'clock. So everyone, first of all, thank you to everyone who's hung out this entire time. To Dave, Guillermo, Kim from Crown Bees, Letta, and Mary, who are the Bee Conservancy team who helped make this event possible. But I would love maybe Dave and Guillermo to either pick a final cue and give an A, or else like maybe your last bee, your bee reflection for everyone who's joining us today.
Let me go as a guest, Guillermo, since you're the owner. Why don't you go last if you don't mind. I'm reading a lot of technical questions here in the piece. We do have, we answer everything. So if you go to our website, bottom right-hand corner, and just plow something into the chat, we'll help you technically understand what it is. So there's that. I'm just thankful that whoever's listening, that you guys are watching and enjoying this. My plug would be, tell your friends and family and neighbors what you've heard. Word of mouth. Guillermo?
Yep, thank you, Dave. Well, first off, I love bee puns. So I have to, say that I hope everyone's hiving a good time. Ha, ha, ha. But I also wanted to give a shout out to ground bees. So as was mentioned earlier, ground bees actually make up the majority of bee species, 70% of them. It's incredible. Bumblebees are one of the ground bee species, mining bees. Now, unfortunately, as we talked about habitat loss, a lot of the habitat that has remained, like at a lot of public parks, it's compacted soil. So those bees do not like that. So if you have a yard, in addition to making sure that you leave undisturbed ground for them, take a look and see if your soil is compacted. If it is, maybe try to loosen it up. You can even add sand to do that, because that actually helps to welcome ground-dwelling bees as well as any other bees you'd like to attract. And those are my parting words. Thank you, everyone, for being here. And thank you, Dave and Rebecca.
Thank you, everybody, so much. We hope you hive a wonderful evening. And just to reiterate Dave's point, tell a friend about something cool you heard today about a bee, and go for a walk and enjoy spring, because spring is here and we can't just spend the whole time cleaning our houses. Get out there and let's do the work together. Thank you so much, everybody.
Thank you.